Hello students, I am continuing with the chapter 1 of physics class 9 motion. Our next topic is uniform acceleration. We have discussed uniform motion, non-uniform motion in the previous class. Now uniform acceleration. Very simple to understand. Acceleration uniformly. What is acceleration? Increasing speed or increasing velocity is called acceleration. Now, uniform acceleration means if the acceleration of a body is uniform, means at a constant rate, it is said to be uniform acceleration. So how can we define it? If the velocity of a body increases by equal amount in equal interval of time, it is said to be uniform acceleration. I repeat, if the velocity of a moving body increases by equal amount in equal interval of time, the body is said to be in uniform acceleration. Next is non-uniform acceleration, means acceleration in non-uniform way. There is acceleration but in non-uniform way. So how can we define it? If the velocity of a moving body increases by unequal amount in equal interval of time, it is said to be non-uniform acceleration. If velocity increases by equal amount in equal interval of time, it is called uniform acceleration. Now the velocity of a body increases but not equal amount in equal interval of time, but unequal amount in equal interval of time. Actually, when we are driving the vehicles on the road and if you are accelerating the vehicle, then that is non-uniform acceleration, because mechanically or manually we cannot increase the velocity of the vehicle at constant rate. So when you increase the acceleration, it cannot be at equal amount in equal interval of time. So the practical acceleration that we are doing while driving the vehicle is non-uniform acceleration. So when the velocity of a moving body increases by equal amount in equal interval of time, uniform acceleration. If the velocity of a body increases by unequal amount in equal interval of time, it is said to be non-uniform acceleration. Our next point is graphical representation of motion. Graphical representation of motion means, so far we have discussed about different types of motion: uniform motion, non-uniform motion, uniform acceleration, non-uniform acceleration, constant velocity, retardation, etc. Now we are going to discuss these different types of motion can be represented graphically with the help of graph. There are two types of graphs used to represent the motion of the bodies. The first one is called distance time graph. Distance time graph, or in short it is also called DT graph. Distance time graph. Remember one basic fact about graphs. If there is time, if one quantity of a graph is time, then that time will be always taken on x-axis. In every graph where time involves, the time will be taken on x-axis and the other quantity will be taken on y-axis. So in a distance time graph, time is taken on x-axis and distance is taken on y-axis. So in a distance time graph, time will be taken on x-axis and distance will be taken on y-axis. This is origin, point of intersection of both the axis, origin. Now I am going to explain the shapes of different graphs represent different types of motion. First one, if the distance time graph is something like this, when you draw the distance time graph of a moving body, suppose you get a graph like this, a straight line moving upwards but in slanting way. This graph represents uniform motion. So, if the distance time graph is a straight line like this graph represents uniform motion. Now, if the distance time graph is a curve, not a straight line, but a curve growing upwards, but not in straight line, but as a curve like this. These type of curve graphs of distance time graph represent non-uniform motion. This is the graph of non-uniform motion. So if the distance time graph is a straight line growing upwards, it represents uniform motion. If it is a curve, then it represents non-uniform motion. Now let us discuss one more shape. Suppose the distance time graph of a moving body is like this. What is this? A straight line parallel to time axis. If the distance time graph is a straight line parallel to time axis, what does it mean? Just try to understand the meaning of this distance time graph. See, how will you get these points? This is 0, say 5. What does it mean? At 0 time, the body has travelled 5 units. Say after 1 unit time, the distance travelled is again 5. After 2 second time, distance travelled is 5. After 3, 5. After 4, 5. What does it mean? Time increases, but the distance travelled is same. When does it happen? Time is increasing, but the distance travelled by the body is same. How can a body cover same distance even though the time is increasing? It is possible when the body is at rest. The body is not moving. After moving a distance of 5 units, for example, the body is at rest now. When the body is at rest at 5 centimeter, but time increases. At different time, if you note the distance travelled by the body, you will get distance travelled as 5 only. But only time is increasing. So, my next point, next shape of graph, distance time graph is a graph which is parallel to time axis. If the distance time graph of a body is parallel to time axis, it represents body at rest. So this is the graph of body at rest. Body at rest. At rest means not moving. So these are the three types of distance time graph: uniform motion, curve, non-uniform motion, straight line parallel to time axis, body at rest. Next graph is velocity time graph. Our next type of graph is velocity time graph. Previous one was distance time graph. Now velocity time graph. So velocity will be taken on y-axis, time will be taken on x-axis. If the velocity time graph is a straight line like this, if the velocity time graph is a straight line moving upward, it represents uniform acceleration. In the previous one we have seen, if the distance time graph had this shape, it represents uniform motion. Don't get confused. If velocity time graph is a straight line growing upward, it represents uniform acceleration. So if the velocity time graph is a curve like this, it will represent non-uniform acceleration. So this is uniform acceleration and this curve is non-uniform acceleration. Now the third type of velocity time graph. Suppose now the velocity time graph is a straight line parallel to time axis. If the velocity time graph is a straight line parallel to time axis, you can just find out, as I told you in the previous case, time increases but velocity is not increasing. Velocity is same. As time increases, velocity is not increasing, not decreasing, but it is constant. So what does it represent? It represents constant velocity. So if the velocity time graph is a straight line parallel to time axis, it represents constant velocity. Now there is two more. Suppose the velocity time graph is a straight line, but this time it is coming down. It started from a higher value, and as the time increases, the velocity decreases. What does this line represent? At 0 time, it had maximum velocity. As the time increases, velocity is decreasing. And how it is decreasing? In a uniform way. That's why you get a straight line. All the straight line graphs represent uniform. Whether it is uniform motion, uniform acceleration, straight line graphs represent uniform. This either going up or coming down. Since it is coming down, it represents uniform retardation. So this graph represents uniform retardation because velocity is decreasing. Now there is one more. Suppose this is the shape of a VT graph, velocity time graph. Velocity time graph is also known as speed time graph. Sometimes you can see in place of velocity, it can be speed time graph also. So velocity or speed are almost same. Velocity is vector, speed is scalar. That is the only difference. So if the velocity time graph is a curve coming down, it represents non-uniform retardation. In a straight line, if it is coming down, it is uniform retardation. If it is coming down in a curve, it represents non-uniform retardation. Non-uniform retardation. So we have seen about 5 types of velocity time graph. First one, uniform acceleration, curve, non-uniform acceleration. Then straight line parallel time axis, constant velocity. This uniform retardation, and this is non-uniform retardation. So these are the different types of graphs that represent different types of motion of the body. The first one was distance time graph. This is speed time or velocity time graphs. All of you practice by drawing these graphs, then only you will understand there is numerical parts also coming as a part of this graph, and in the next class we will again use this velocity time graph for another very important thing. So you must understand the basics of these graphs and its shapes. Okay, please practice. Till then, bye.